Hello everyone, welcome to the next lecture. So in this lecture, let's start with graphing polynomial functions. So what are the steps that we need to sketch the graph of a polynomial function? Number one is to find the intercepts. So you have to find x and y intercepts. Second is to check for symmetry. So symmetry represents whether both the ends are pointing upward or downward. So that difference is here comes from the fact that we have to check whether it's an even function or an odd function. If it's an even function, we can check based on f of minus x. If f of minus x is equal to f of x, it's an even function and it's symmetrical about the y-axis. And if the function is an odd function, it's symmetrical about the origin, where f of minus x is equal to negative f of x. So then we can use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercept. So if the multiplicity is even, it just touches the line. If it is odd, only then it crosses the line. Next, we have to determine the end behavior by examining the lead term. So if the lead term is negative, it's downward. So if the lead term is negative, it's downward. If the lead term is positive, it is upward. And depending on the even function or odd function. So next, we have to ensure that the number of turning points does not exceed 1 less than the degree of the polynomial. So next, seventh one, optionally use a technology to check the graph. So you can use different sketching calculators online as well, or graphing calculators, to check whether your result is correct or not. So first things first, let's start with the problem. First we have to find the x-intercept and the y-intercept. So how would you find the x-intercept here? Put f of x equal to 0, so it becomes x plus 1 equal to 0, x minus 4 equals 0, and you have another one which is x plus 1 equals. So x equal to negative 1 and x equal to negative 1 and x equal to 4. So there are two negative ones, which means that it has a multiplicity of 2. So which means at negative 1, it just touches the point. And you have another one which is 4. Next we have to find the y-intercept. So put f of x, put x equal to 0. So find f of x. So then it becomes minus of 0 plus 1 square times 0 minus 4, so it becomes plus 4. So this is the y-intercept. So the other point, so this y-intercept becomes 0, 4. So you have negative 1, 4. So negative 1 and 4 can be written as negative 1, 0 and 4, 0. Next we need to find the next one is the end behavior. End behavior is depends on the lead term. So lead term is negative 1. So which is negative, and the function, the whole power of the function is cubed. So if it's a cube, we know that it is an odd function. So it is negative and odd. So we know that when it is negative and odd, so the both ends, so here it becomes upward, on the left side it's upward, on the right side it is downward. So we have that part done. Next we have to find the number of turning points. So here the power is 3, so there is only 2 turning points in this graph. So note down the points. So let's consider that this is negative 1 here, and you have 4 right here, and you have 0, 4 right here. So this is 4. So these are the 3 points. So we know that the multiplicity on negative 1 is even. So when the graph comes here, it only touches the graph. Now at 4 it cuts the graph, and then at this point 4 here, it is even or odd multiplicity, so it's a straight line. So this is the graph here. So this is the graph for this particular function, and this is how you can determine the graph. So first thing we need in the intercepts, and using the intercept find the multiplicity. Next find the y-intercept. Next check the lead term if it is negative or positive, and then check whether the function is even or odd. If the power is even, it means it is an even function. If the power is odd, it's an odd function. So that's how we can determine it. So use the same principle now. Here you have so you have 1 by 4 times x minus 1 to the power 4 and x plus 3 to the power 3. So pause the video right here and try to solve this problem. Next, how do you write the formulas for polynomial functions? So given the graph of the polynomial function, we can also write the formula for the function. For the first thing, we need to define the x-intercept and find the factors of the polynomial. Examine the behavior of the graph at the x-intercept to determine the multiplicity. And third, find the degree of the polynomial of the least degree containing all the factors found in the previous step, and then use any other point to determine the stretch factor. So let's find the idea here. So you have -3 here, -2, 3 and 4. So the values are -3, -2, 3 and 4, and it passes through the point 0, -3. Now notice that all of them here they are crossing the actual graph. So which means if they cross the actual graph, there's multiplicity, the least multiplicity that we can give them is in 1. So we can write the equation as x minus 3 times x minus 2 times x minus 3. So x plus, so let it write this way. So x equal to -3, x equal to -2, x equal to 3 and x equal to 4. So push everything on the other side, so it becomes x plus 3 times x plus 2 times x minus 3 times x minus 4 equal to f of x. So this is the least powerful function that we can write, and we do not know the multiplicity specifically. So what we can do now is pass it through a certain point. So pass it through this point and determine what would be the value for that point. What would be the value? So let's consider that this is some value k. We do not know that k value. So we have to find, now we know that both ends are pointing downwards, so which means that this is going to be negative as well. So k should be negative. So substitute this point into this equation and find out the value of k. So we know that this is f of x and this is x. So this becomes k times 3 times 2 times -3 times -4 equals -3. So -3 gone, k becomes 3 times 2 times 4 is -24. So 1 by -24. So this equation can be written as f of x equal to -1 by 24 times x plus 3 times x plus 2 times x minus 3 times x minus 4. So this is how we can determine the stretch factor for the equation and determine the polynomial function. So use the same principle now and try to write the formula for this one here. So notice that at -1 you have a single touch, which means that there is an even multiplicity here. So this is an odd multiplicity, but this odd multiplicity is greater than 1, and here it's an odd multiplicity, so it crosses the point and it can be equal to 1. So use these principles now and pause the video right here. It passes through the point 0, -4. So pause the video right here and try to solve this problem. In this lecture, let's talk about dividing the polynomials. So how do you divide a polynomial? So if the division has only one term, so we can split the term into a single fraction. So this is how we can divide using a monomial. So split each individual term and write down the actual values, and finally take out the common terms. So this is the one that divides it, is the divisor. So when you split up the polynomial and finally reduce each fraction, so when you reduce each fraction, take out the common terms. So the first one becomes 3x cubed, second one becomes 4x squared, the third one becomes x, and fourth one becomes 2. So write down the net equation. That net equation becomes your final answer. The next method is talking about long division. So we are using the same principle as that of the general division for integers, but here we have to divide using the polynomials that we do have. So the long division method involves taking the common terms and taking out the ones and continuously doing the process until you get a value that does not undergo any further division. So this value here is called as the remainder. And how do you do this in terms of let's try a simple example here. So let's discuss how do you do long division. So let's say we are dividing x squared plus 8x minus 5 divided by x minus 3. How would you do this? So in long division method, we use x minus 3 on the side, and we can write x squared plus 8x minus 5 here. And now we have to find out the first term. So take the first term in both of them and divide each other. So divide the main dividend by the divisor. So this here is called as the divisor. So this here is called as the dividend. So divide the dividend term by the divisor. So that value becomes x here. So now use this principle here. So now we are multiplying. So write down that multiplying value x on the top. Now and to multiply the entire term with x and write down the value at the down part. So x into x becomes x square, minus 3 into x becomes minus 3x. So next thing that we want to do is change the sign. So changing the sign basically means that use the second part. If there is a positive on the top, write negative. If there is a negative on the top, write positive. So we are basically changing the sign. So when you change the sign, it becomes x square minus x square, which becomes 0. Next you have 8x plus 3x, that becomes plus 11x. Next write down the third term that we have left, minus 5. Now we just have 11x plus 5. Next again use the first term 11x and divide it by x. So 11x by x becomes 11. So write down here plus 11. Plus 11, multiply it with the 11 now. Remember that we have multiplied with x now. Next we have to multiply 11. So 11 times x is 11x. Minus 3 times 11 is minus 33. So again change the sign. So there is plus here, so minus, minus here, so plus. So 11x and 11x are gone. Now you have minus 5 plus 33, that becomes plus 20. So this here is the remainder. But the difference here is that how would you write the answer? Is that this here represents the quotient, and how would you write the actual quotient in total is we can write it this way. So x square plus 8x minus 5 can be written as x plus 11. Next we have also write the remainder plus write down the number 28 and divide it by the divisor, right? So x minus 3. So this is how we can write this value here. This is how we can write that. So this is the process of long division. So this is a much more arduous method. So that's the reason why this method is not so common, and we use another method to do it much more simply and easily. So it's called as the synthetic division method. So let's try that method now. So you have x cubed plus 6x square plus 8x minus 2 divided by x plus 3. Again remember, this is the divisor, this here is the dividend. First take the divisor and equate it to 0 and find the value of x. So that is minus 3. Next what we do here is write down the same format as long division, but this time write down here just the number negative 3. Next what do we write inside here? We do not write the entire value, just write the coefficients of each value. So here there is nothing, so which means there is 1, and here you have plus 6, you have 8, and you have negative 2. Remember that if there is a x value that is missing in the power, so write down that value as 0. So do not skip any values, always write the entire values. Now what do you do first here? So the starting process involves writing 0 and add both values. So 1 plus 0 becomes 1. Next multiply this value with this value. So 1 times negative 3 becomes negative 3. Next again add both values. You get 6 minus 3, which is 3. Next again multiply this with the negative 3. 3 times negative 3 becomes negative 9. Next again add both values. 8 minus 9 is minus 1. Again minus 1, multiply it with negative 3 here. You get becomes 3. So negative 2 plus 3 becomes 1. So this here is the remainder. Now what do we have here in the reverse? So come from this side. This is the remainder. So this is the constant. This is the power x, and this is the power x square. So this is how we can write it down. So now basically write down this value here. So this is the first place, this is the x place, this is x square place. So multiply the two values and add each of them. 1 times x square is x square, plus you have 3 times x, plus minus 1 times 1, so it becomes minus 1. So this here represents the quotient, 1 here is the remainder, and x minus 3 here, x plus 3 here is the divisor. Now, so how would you write this equation here? So this can be written as x square plus 3x minus 1, and write down the remainder. Remainder is plus 1, so plus 1 over, write down the divisor, x plus 3. So this is the answer. So this is how you do synthetic division. So this is the method that we use for synthetic division. So let's try another problem. Let's try a much more complex problem. So you have, let's say we have x bar 4 minus 4x square plus 6 divided by x minus 4. So again, first divisor equated to 0. So x minus 4 equals 0. From this we get x equal to 4. Next, write down the long division form and write down the value 4 here. Now notice, write down the coefficient. So for x bar 4 the coefficient is 1, but notice that in the reverse when you go, x cube is missing. So if it is missing, write 0. Next you have x square, which is negative 4, the coefficient is negative 4. Next x is missing, so write 0. Next you have 6. So remember that if something is missing, write down 0 there. Next again the process, put 0, add the two values, you get 1. Next multiply 1 with negative 4, 1 with 4, so you get 4. 0 plus 4 is again 4. Again multiply it with 4, you get 16. Negative 4 plus 16 is 12. Again multiply 4, you have 48. 0 plus 48 is 48. So 48 again times 4 becomes 192. So add the two values, you get 198. So 198 here is the remainder. Next you have 1 x square, x cube. So multiply the two values and add them. So 1 times x cube, so x cube, plus 4 times x square, plus 12 times x, plus 48 times 1 is 48. So this here is the quotient. So how will you write for this here? So we can write that this value is x cube plus 4x square plus 12x plus 48 plus, you have 198 as the remainder. So 198 by, write down the divisor, x minus 4. So this is the answer. So next one we want to do is understanding what happens if your answer becomes 0. So this here is what we call the factor theorem. So factor theorem basically says that if you divide two polynomials and the remainder is 0, then the monomial is a factor of the polynomial. So then the divisor, is the factor of the polynomial. So this here is called as the factor theorem. The other one to remember is called as the remainder theorem. So the remainder theorem basically says that the dividend is divisor, the dividend is quotient plus remainder times the divisor. So this is the formula that we can use to find the relationship between dividend and the divisor. So with that we end our lecture on the synthetic division method. So the method is called as synthetic division. So try some more problems from the textbook so that you understand it better. Next, let's talk about the last topic, rational functions. So in this section, we'll talk about arrow notation. We'll solve applied problems involving rational functions. We'll find the domains of rational functions, identify the vertical and horizontal asymptotes, and finally graph the rational functions. So this is an example of a rational function. So the function that you see here is f of x equal to 1 by x. So the graph goes towards infinity, and it goes towards negative infinity, but it does not have a value at 0. So the domain here for f of x equal to 1 by x is negative infinity comma 0 union 0 comma infinity, where we are basically removing the value 0 by itself. Now as x approaches the value, it starts going towards the smaller values. As it becomes closer and closer to 0, it reaches high values. The same thing as you go negative, so more towards 0, it approaches infinity, and as you go far away from infinity the values, it starts approaching nearly 0. So what is the asymptote here? So we generally can find two asymptotes, vertical and horizontal asymptote. Vertical and horizontal asymptote is the line that divides the graph into two equal parts. So a vertical asymptote is the vertical line x equal to a, where the graph tends to go towards positive or negative infinity as the input approaches a. So here, this line here represents the vertical asymptote. The horizontal asymptote is the horizontal line y equal to b, which separates the graph into two parts again. So this is the horizontal asymptote. So this is the horizontal asymptote, and this is the vertical asymptote. So the equation will be x equal to a for the vertical asymptote. It's y equal to b for horizontal asymptote. So our idea is to find the values a and b to find the asymptotes for the two values. So they're asking you sketch the graph of reciprocal function shifted down 1 unit and left 3 units. So they're asking you to find the one that shifted down 1 unit. So notice that what is the main purpose here is that both the points, notice that here it passes through 1 comma 1 and here it passes through negative 1 comma 1. So these are the 2 points based on which you move either horizontally or vertically. So if it moves 1 unit, shift down 1 unit and left 3 units. So notice that these are the 2 points. So they have to shift down 1 unit, so down 1 unit, and left 3 units, so 1, 2, 3. This will be the point. Now here again, this one also will have to move, shift down 1 point, and then 1, 2, 3. So these are the 2 points now. What do we do now is that this is the axis here. How would you write the axis? The axis is the one that divides the two lines into two parts. This is one line, and this is the second line. So this will be the graph. Here it will be this way here. This is the graph, and on this side here, this is the graph. So this is how we can write the graphs for the 2 points here. So use the same principle now. Here they're asking you to shift right 3 units and down 4 units and sketch the graph. So pause the video and try to solve this problem. So what is a rational function? A rational function is a function that can be written as the quotient of the two polynomials p of x and q of x. So you have two different polynomials that are dividing each other. The division of the two polynomials is what is written down as the quotient. The quotient itself becomes the rational function. So this is a general graph of a rational function. Now, how do you find the domain of a rational function? First things we need to do is to make sure that we equate the denominator equal to 0 and eliminate any value that creates the denominator equal to 0, that the rest of the values become your domain. So your condition here is x square minus 1 equal to 0. So which is x plus 1 times x minus 1 equal to 0. X plus 1, sorry, not equal to 0. And x minus 1 not equal to 0. So x not equal to minus 1, x not equal to 1. So these two values to be excluded. So then the domain becomes negative infinity comma negative 1 union 0 comma 1 union 1 comma infinity. Notice that here we are eliminating -1 and we are eliminating 1. So eliminating the two values is really important. Eliminating whatever the values that equate the denominator to 0 is the main reason for solving these problems. So use the same principle now. Pause the video right here and try to find the domain of this function. Next, let's talk about how to identify the vertical asymptote of a rational function. First things that we need to do is to factor the numerator and the denominator and note down any restrictions in the domain of the function. Third, reduce the expression by cancelling the common factors in the numerator and the denominator. Number 4, note any values that cause the denominator to be 0 in the simplified version and where the asymptotes, vertical asymptotes will occur. So note that any restriction in the domain where asymptotes do not occur, these are generally called as the discontinuities or holes. So let's start with the factors here. So here you have k of x equals x by x square plus 5x. So you have x by, in the down part we can take x common, so it becomes x plus 5. So x gone, so you have 1 by x plus 5. Now write down the restriction that we have. So the domain restriction is x plus 5 not equal to 0, x not equal to -5. So that restriction here this here is the vertical asymptote. So the domain restriction itself acts as your asymptote. So this is how we can find the asymptote of the function. So use the same principle now. Pause the video right here and try to solve this problem. Next, let's find the horizontal asymptotes. So remember that so there is no specific way to actually find the horizontal asymptote. We generally use the three main principles here. We can determine it based on the degree of the numerator. So if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equal to 0. If the degree of numerator is greater than the degree of the denominator by 1, then there is no horizontal asymptote. So it has a slant asymptote. So it will have something like this. So it's not a perfectly horizontal one, but it's a slant one. But if the degree of numerator is equal to the degree of denominator, then you will have a horizontal asymptote at the ratio of the lead coefficients. So the ratio of lead coefficients itself becomes the asymptote here, when you have degree of the numerator equal to the degree of the denominator. So here, first things first, find the degree of the numerator and denominator. So which is 3 and 3. So 3 equal to 3. So which means here the ratio of the coefficients. So the coefficients are 5 and 10. So y equal to 5 by 10. So y becomes 1 by 2. Next, we have the next one. We have the degree of the numerator is 2, degree of the denominator is 1. So here 2 is greater than 1. So which means here it's going to have a slant asymptote. Next we have x square and x cube. So here 2 is less than 3. So which means the asymptote is y equal to 0. So this is very good. So this is how we can solve the problem. So use the same principle now. So let's try and identify the horizontal asymptotes. So pause the video right here and try to determine the horizontal asymptote for this problem. So now let's find out the actual asymptotes, the horizontal asymptotes. So a rational function will have a y-intercept at f of x equal to 0. And if the function is defined at 0, now a rational function will not have a y-intercept if the function is not defined at 0. So likewise, a rational function will have x-intercept, that the inputs that cause the output to be 0. Since a fraction is only equal to 0 when the numerator is 0, so x-intercepts can only occur when the numerator of the function is equal to 0. So the same principle here, again, f of x equal to 0 for x-intercepts, x equal to 0 for y-intercepts. So to find x-intercept now, put f of x equal to 0. So 0 equal to x minus 1 times x plus 3 by x minus 4. So you get x minus 1 times x plus 3 equals 0. X minus 1 equals 0, x plus 3 equals 0, x equal to 3, and x equal to 1 and x equal to negative 3. Next, how do you find the y-intercept now? Put x equal to 0. So when you put x equal to 0, f of x value becomes, f of 0 is the y-intercept, becomes 0 minus 1 times 0 plus 3 by 0 minus 4. So this value becomes, f of 0 minus 1 is minus 1 times 3 by negative 4, minus minus gone, so f of 0 becomes 3 by 4. So the equation for the y-intercept here is x equal to, so y equal to 3 by 4, and for x-intercept you have two different vertical asymptotes, so that is x equal to 1 and x equal to negative 3. So with that, we end our lecture on polynomial and rational functions.